Hello everyone, welcome back to my class. So again today I'll be taking you differentiation, and then today we'll be looking at general formula. So we have looked at first principle in my previous video. So today we'll be looking at general formula, and I'll just go straight to how to do general formula. Okay, how to solve calculus using general formula. So general rule is that if y equals to x raised to power n, the y dx equals nx raised to power n minus 1. Also, if y equals ax raised to power n, the y dx equals anx raised to power n minus 1. So these are the general rules you can use in solving general formula. So let's take questions. So let's look at different examples. Let's say we have y equals x raised to power 7. Using the general formula, we have the y dx equals 7x raised to power 7 minus 1, right? Because the 7 is our n. Okay, so here we have n x raised to power n minus 1. So since we have 7 as our power here, we are having 7x raised to power 7 minus 1. Therefore the y dx equals 7x raised to power 6. Alright, good. So that's example 1. Let's look at another example. Let's say we have y equals 2x raised to power 4. So here the 2 is representing a, and then the 4 is representing n. So to do this, we follow the same procedure. The y dx equals a, which is our 2 in this question, n, which is our 4. That's n 2 times 4 times x raised to power 4 minus 1. So that's equals 2 times 4, which is 6. 2 times 4 is 8. x raised to power 4 minus 1. So 4 minus 1 is 3. So we have the y dx to be equals 8x raised to the power of 3. So this is how you solve differentiation using general formula. So we can do more questions. Let's look at more difficult questions. Okay, a bit, not so much. So let's say we have question like y equals x raised to power 3 plus x raised to power 2 plus x plus 5. Okay, so how do we use general formula for this? So we say to this general formula, we say the y dx will be equals to 3 x raised to power 3 minus 1 plus 2 x raised to power 2 minus 1 plus the power of x here is 1, so you say 1 times x raised to power 1 minus 1 plus this is 5. It doesn't have a power. 5 is not having a power. So when we differentiate the constants, it's actually equals to 0. So here we have 3 minus 1 is 2. So we have 3x raised to power 2 plus 2 minus 1, we have 1. So the power of x is 1, so we have 2x plus we have 1 minus 1 is 0, so we have 1 times x raised to power 0, and x raised to power 0 is 1. Therefore we have 3x squared plus 2x plus 1. And these are our final answer. Let's take one difficult question. Let's say we have y equals 1 over x. Alright, if you watch my first video on YouTube, you will have seen me solve this question from the first principle. Okay, or if you watch my other TikTok videos, you must have seen that I've solved this from the first principle y equals to x raised to power 1 over x. So in order to solve this using general formula, we are going to rewrite y. If you have done indices, you should remember this. If you have not done indices, you can say it in the comments so I can teach on indices, right? So here we have x raised to power minus 1. Okay, so 1 over x becomes x raised to power what? Minus 1. X, not n, x raised to power minus 1. So we can then use the general formula now. So we say dy dx equals minus 1 x raised to power minus 1 minus 1. This minus 1 is our n. So based on the general formula, when we have x raised to power n, dy dx equals to n x raised to power n minus 1. So here the same thing has been done. We have our n to be minus 1, so we have minus 1 x raised to power minus 1 minus 1, right? So we have minus 1 multiplied by x. Minus 1 will give us minus 2, so which means we have minus x raised to power minus 2, right? So we have minus this minus over 2 will be the reciprocal of x, so we have 1 over x like this, x raised to power 2. Okay, so another question that looks like this, very sweet question. Let's say we have y equals to the square root of x. So how do we solve this? Is general formula, the same method. We write y, right? From our index notation, indices, we know that y could be x raised to power 1 over 2. This is called, in indices, this is called negative index. And in indices, this is called fractional index of half. Right? So we have y equals to x raised to power 1 over 2. So we can therefore differentiate by saying dy dx equals 1 over 2 multiplied by x raised to power 1 over 2 minus 1. Right? So when you do 1 over 2 minus 1, LCM is 2. You have 1. 2 times minus 1 will give us minus 2. So our answer will be minus 1 over 2. Right? So we say dy dx equals 1 over 2 x minus 1 over 2. Right? So we can see dy dx equals 1 over 2 multiplied by this negative sign becomes 1 over, then we have x raised to power 1 over 2, right? The x raised to power 1 over 2 will give us the square root of x again. So we can say therefore we have 1 over 2 multiplied by 1 over the square root of x. Therefore our final dy dx equals 1 times 1 over 2 root x. Okay, so this is a short way of solving general formula, and I sincerely hope you understand all I've solved. Yeah, it could be in form of polynomial like this, so, and I've done justice to that. So if you have question in the comment section, you should let me know. Thank you for watching.